So in 2.5, we'll look at some more things we can do with graphing. We'll start off with 6 functions that you should know the shapes of their graph. So for these, I would suggest putting the graph on one side of a flashcard and the function and its name on the other side so you can just memorize them. If you memorize them, it'll be much faster when you do your homework and when you do your tests and quizzes, and you'll just need to know them. So the first one is the identity function. And the identity function goes straight through like that. It crosses at 1, 1 here, 0, 0 here, and -1, -1. It's the equation y equals x, and it's called the identity function. The absolute value function goes like that. It makes a V, and that's the way I remember it because value starts with V. It goes through -1, 1, 0, 0, and 1, 1. And the equation looks like an absolute value with an x. The third out of our 6 is the quadratic function. And the quadratic function also goes through -1, 1, 0, 0, and 1, 1. But it makes a curve. It's like a U. And quadratic functions look like x squared. Anytime there's the squared is the highest exponent, it's a quadratic function. The fourth of our functions is called the square root function, and it goes through 0, 0, and 1, 1. But it kind of curves up and over like that. Some students have said it looks a little bit like the square root that's in the problem, like the square root of x. The cubic function goes through -1, -1, 0, 0, and 1, 1, just like the identity function does, but it's also a curve. It curves up and then over and then up, kind of like an S. And the cubic function is x cubed. And the last one is the cube root function. And it goes through -1, -1, 0, 0, and 1, 1 also. But it's a little bit more like the square root. This part kind of goes up and over, and then it curves through here, and then it comes down and over. And the function looks like a root, but there's a 3 there. That makes it a cubic root, a cube root. So it's like a square root with another part added to it. The other thing we're going to do with this is, with these shapes, is move them left, right, up, and down. So if something is added outside the function, it moves it up. If it's subtracted outside the function, it moves it down. If it's inside the function, it's backwards from what you feel like. Okay, and that's going to be true in a lot of different situations as we move forward for things inside parentheses. So when it's inside and it's added, it moves left. When it's inside and subtracted, it moves right. So inside is left and right, outside is up and down. So let's look at some examples. So this is the absolute value function. So we're going to start by drawing the absolute value function on our graph. If you have a pencil, that'd be good. You just lightly pencil it in. But the absolute value function is a V, and it goes through -1, 1, 0, 0, and 1, 1. So this -2 is outside the absolute values. That means it's outside the function. And because it's minus, it's really telling us that we're going to move that graph down 2. So it means this point that was here would get moved down to, this point that was here would get moved down to, and this point that was here would get moved down to. The shape of the graph stays exactly the same. It's still going to be a V. It still has the same slant to those lines. It looks like that. And that's our final graph. So the first thing we need to recognize is that this is an x squared equation. That means it's going to be a parabola. It means it goes through 0, 0, 1, 1, and negative 1, 1. But it's a curve like a U. So that's our original shape. This plus 3 on the outside is on the outside, so it means we're going to move up 3. So we take each one of those points and we move them up 3. And that gives us this curve, the same U shape, just up more on our graph. And that's our final answer. So the first thing we have to recognize that this is really a square root graph. So our original square root graph starts at 0, 0, 1, 1, and it curves up and over. This minus 4 is inside. It's minus, so that tells us we're going to move right 4. And this is where I say it feels backwards, because it feels like a minus should move it left, but because it's inside, it's backwards from what you feel, and it actually moves it right. So we go right 4 for this point, and right 4 for this point, and then we would draw the same shape. And that's our final graph. So the idea here is to be able to tell from the equation quickly how we move it and then draw a sketch of the graph in the right shape in the right place. So because this has a squared in it, it's an x squared graph. So we're starting with these 3 points, and it's a curve like a U. This plus 1 is inside. Inside's backwards from what you think, so it would be to the left 1. So it would be right here, and right here. And that's our final answer. Now in this situation, we have numbers inside and outside, so we're going to move it 2 different ways. But the first thing we need to see is that this is a cubic function because of the exponent of 3. That means the graph that we're starting with has 3 points in a row like that, but it's curved through those 3 points. Like that. The minus 1 inside tells us that we're going to move it right 1. The plus 2 on the outside tells us that we're going to move it up 2. Okay, so we'll take those 3 points. We're going to go right 1, up 2. So we'll go right 1, up 2, ends up there. Right 1, up 2, ends up here. Right 1, up 2, ends up here. And we'll draw our curve through those 3 dots. And that purple graph is our final answer. Let's look at another one. So in this case, we can see the squared. That means that we're starting with the graph of x squared. So it would look like this to start off with. The plus 1 is inside, so that tells us we're moving it left 1. The minus 3 is outside, so that tells us we're moving it down 3. So each one of those points we're going to go left 1, down 3. Left 1, down 3, and left 1, down 3. So we get those 3 points, and then we'll draw our curve, U shape, through those 3 points. And that green line is our final answer. So in this last example, we're going to take a graph that's been given to us and then move it. So it's important to recognize kind of where some points are. We have a point right here, a point right here, a point right here, and a point right here. And those points are going to help us because that's what we'll move. So this has a -1. It's inside the parentheses. That means we're moving it left to right. And because it's minus, we're moving it right. So this is telling us that we're going to move this graph right 1. So this point is going to move right 1, which means it'll end up here. This graph will move right 1, which means it will end up here. This graph will move right 1, which means it will end up here. And this graph point will move right 1, which means it will end up here. And then we just connect the lines, connect those points, I mean. And that purple graph is our answer to this problem. So it should look exactly the same as the graph we started with, except that the whole thing has been shoved to the right 1. Part B, I copied the graph again just so that we would have it on this screen to look at. We've got a point here, point there, and a point there. This has got a +2 inside. So inside means left to right, and because it's plus, we're going to move it left 2. And then the outside says -1. That tells us we're going to go down 1. So every point will go left 2, down 1. So we'll go left 2, down 1, which gives us a point there. So let's see, that's -5, -1, a point right there. This point will go left 2, down 1. So it's -3, 2. This point will go left 2, down 1, so that's -1, -1. And this point goes left 2, down 1, so that would be at 1, -1. So we would connect those dots, and that's the graph for that problem.